And hello, everyone, teachers, students, welcome to day 3 of our Computer Science Education Week, where we are going to be coding in CS First again, this time creating our very own Dino game. If you've been with us all week, you know this already, that we always want to start with a land acknowledgement. And so again, I'm just going to point out that link again, that native-land.ca. I'd love to know how many of you have taken a look at that website and learned about the land around you. And if you have been here before, you know there's a form where you can speak with us. If you already know about that form, go ahead and let us know. What lands are you on and what cultures and nations are around you? Um, as I had mentioned last 2 days, Treaty 7 territory in Calgary is where I am from, and just so thankful that we have just all of these beautiful lands around us. Okay, let's move on to who we are. So I already mentioned, I'm Michelle, I'm in Calgary, and we have Guillaume back with us again. Hey Guillaume, what's new with you, and what treaty lands or territories are around where you are?
Well, I'm from Sherbrooke, Quebec. The treaty itself is slightly more complicated, but we have the Abenaki and Wabanaki people in the region, and it's a beautiful land, and I'm really happy today because it's snowing outside, and we get to be part of this wonderful community here. So I'm really excited, and I'm also on a different land today. So the 2 previous days I was in Val des Sources, Quebec, a smaller city, and today I'm in my home office, and you can see in the background I have my 3D printer and all sorts of projects and Legos in the background. So I'm all this is my usual workspace.
Ah, nice. I love it. And Remy, I just want to say thank you to you, Remy, who is on Treaty 57 territory. That's just wonderful that you know that. Those of you out there, if you want to communicate with us, I'll give you that link again in a second. But let's make sure to just remind teachers, if we're going too quick at any point, you just pause us. We'll be here when you get back. If you need to rewatch something, go ahead and rewind. And of course, all of these replays will be available into infinity, so you can watch them over and over and over. And thank you so much, teachers. Whoops. I'm going to tell you first about this, and then we'll thank the teachers. So students, if you didn't have that link to communicate with us, here it is again, the cc page, CS First, same link we've been using the last 2 days. Go ahead and post your name in there and let us know whose land are you on. And those of you that are crying, asking for a shout out, we're not going to give shout outs today unless you're answering our question. So go ahead, post that in there, and hopefully then we'll get you a shout out. Now, the thank yous. Lots of thank yous. Sandy Curry from Google Canada, STEM Program Manager. So thankful to her for all she has done to bring together volunteer Googlers and really building this program with CS First, as well the team from CS First down in United States. We were hoping to have Josh here today, but he couldn't make it last minute. But Josh says hello, even though he couldn't be here. And you met Cassandra on Tuesday. You met Brendan yesterday, and we have Brendan back with us today. Hey, Brendan, how are things going? I wonder if maybe Brendan is frozen.
Looks like it.
Look at that. Technical issues even happened to Googlers. But hopefully we'll get Brendan back and he'll be able to say hello. We're thrilled to have him here again with us. And Guillaume, what do we have in that form? Do we have any students answering my question?
Hmm. We have, I believe, Mrs. Riley's class from Mississauga. And we have.
Mississaugas of the credit. Excellent. And then,
Yes.
yes, Emma, Treaty 6. Thank you, Emma, for letting us know that. Oh, and we have Miss Riley's class. So they're the Anishinaabe, Treaty 5. Oh, Embry, Santagan in Utah. Wow, that's excellent. I'm so glad to hear just about the lands in Utah. Wonderful. Um, all right, let's see. It looks like Brendan may have jumped off. Hopefully he'll jump back in again. I think this is also the time teachers, those that were posting on social media yesterday and the day before, it was so, so great to see the work that your students are doing. Keep going. Tag Code with Google, CS First, and CS Ed Week. And of course, if you tag us at the Cobblestone C, we'd love to see that there as well. All right. We have Googlers with us again. You guys met Brooke yesterday if you were with us. And we have Peter is here with us as well. Let's start with you, Brooke. You want to say hello and tell us a little bit about yourself in case people weren't here yesterday?
Sure, definitely. Hi, I'm Brooke. I grew up in Peterborough, Ontario. I went to school down in the US. I took computer science and computer engineering dual major. While I was there, I actually played soccer. So I mentioned this yesterday. Having a career in computer science wasn't fully on my radar because I cared more about soccer. It wasn't until later I realized how much I absolutely loved to program and loved solving problems. So I shifted focus and I got my job at Google. So now I'm in the Waterloo office and I work on the Stadia team. Actually wearing a jacket, woohoo. Stadia is Google's game streaming from the cloud. So this way you can play games on any device and you don't need a console or a big PC to do it anymore. So very excited to be here today again.
Very cool. And I love that you started coding when you went to university. And these students here with us today, some of them probably are in grade 2 and 3 and they're already starting coding. So
it's just incredible. I wish I had the same sort of opportunity and you guys are going to be so far ahead, which is just amazing.
So good. And Peter, welcome, Peter. You want to tell us a little bit about yourself?
Sure. Hi, my name is Peter. I'm really excited to be here. I grew up in Kelowna, British Columbia. I did university at the University of Waterloo. Now I work in the Waterloo office, just like Brooke. It was so I work on the Chrome web browser, mostly on web APIs.
Nice. So that's so cool. Students, I bet you use Chrome, and it's Peter that does the computer programming, one of the computer programmers for Chrome. And look who else we have back. Brendan, you're back. Great to have you.
Hi, I'm so sorry my internet cut out on Computer Science Education Week. It must be because there's just too much amazing things that are happening on the internet around computer science and coding and creating projects. But I just wanted to come back again and just say how amazing it was to watch all of your escape room projects yesterday. And if you're back again, thank you for taking the time. And if today is your first day, I hope you have an amazing time with Peter and Brooke, because I think they're amazing Googlers that I get to learn from a lot as well. So have a wonderful day today, and thanks for letting me come say hi.
Wonderful. Thank you so much, Brendan. And I know you're going to be watching us from backstage, but appreciate your support so much and have a great session. All right, you guys, let's just see. We have so many people here. Lydia is from Santaguin territory. We have Shanice is here, and Carter is here, and Vincent, hello. Ellie, hello. Tyrone, Sophie, wow, we have so many students here ready to learn. Guillaume, do you want to let everyone know what the plan is for today?
Absolutely. Today we will be working on a video game. So some of you might be familiar with the Dinosaur game that's built into Chrome. So if you're trying to go online and there's no Wi-Fi, there's that little dinosaur game that pops up in the browser, and then you get to jump around. So we'll take a look at that in a few seconds. So we will try to reproduce that, reverse engineer that game, and try to figure out how to make our own. And that will be your challenge. So we'll take a look at that game. We'll talk a little bit about reverse engineering, and we'll take a look at the code behind that. And of course, we have Brooke and Peter, and they'll be coding the same project. And Peter will show us another game that he's been working on for a few hours now. So that should be fairly impressive near the end. I really look forward to seeing what he came up with. And finally, we'll talk about submitting your projects and saving your work. And we'll talk about what's coming up in the challenges for December 15th, because we have another workshop on December 15th for all those projects to showcase your work.
Yahoo, that's going to be so great. And teachers, you've got information on how you're going to be able to get student projects to us. We'll give you more details about that later, but I think, Yum, we should get going. Did you want me to share your screen now?
Of course, why not?
Here we go.
All right. So you can see I'm in my presentation right now. I'm in my web browser, my Chrome web browser. Thank you, Peter, by the way.
You're welcome.
I don't want to disconnect my Wi-Fi to show you, otherwise I wouldn't be able to show you, but I have a Chrome extension that is the Dino game. So it lives in my Chrome extension bar here at the top. So let me just turn that on. There we go. And we have the little, oh, I forgot to jump. So there's a little dinosaur and there are obstacles moving across the screen. So we have the impression that the dinosaur is walking and moving forward. So let me restart that. I'll try not to die so quickly this time. And and you have to jump. So jump with the space bar, jump over obstacles. And if you don't, you're game over, and that's it. And we have a score in the top right corner. So my score isn't very good. Peter, have you played this game before?
Yeah, I've had Wi-Fi issues too often, so I've played it a lot more than I would care to admit.
So do you have a personal high score?
I probably do, but I don't remember what it is.
Maybe that's another great question for students in that form. If you want to let us know, have you played the dinosaur game before? And if so, do you remember what your high score was? Let us know in the forum and maybe we'll give you a shout out. I do want to shout
Have you ever played it long enough that you've gotten into the night mode?
I don't believe I have. There's a night mode? I didn't know that.
There is.
That's
Wow.
awesome. We have, so Kevin has played the game before. Oh, Heather says 5,000 is their score. Santosh, yes, they've played it. Emerson has played it. Oh, Meet from Miss Harper's class has never played the dinosaur game. That's okay. We're going to create one that you're going to be able to play today.
Mm-hmm. So don't go play it right now, though, because it means you need to disconnect your Wi-Fi. So don't do that now. Stick with us and we'll show you how to do it. So in that chat, can you help me identify the different functions, the different bits of code that the different actions the dinosaur can actually do in the game? So let me know in the chat. So what can that dinosaur do? So you saw the live demo of me playing the game. So let me know in the chat what that dinosaur can actually do. So Brooke, what did you notice? The first thing that you saw in that game? What can that dinosaur
I see Olivia saying that the dinosaur can jump.
I think that's the first one. Dinosaurs can jump. That's good. What else?
I saw that it ducked.
Ooh.
Yes. So there are obstacles on the ground and also flying obstacles, and you have to duck. So that's true. But that dinosaur can also do something else.
Run.
So there's kind of an animation. We get the sense that the dinosaur is moving. Is it actually moving though? I'm not sure.
Ooh.
That's a good, interesting question.
We have so much engagement in the forum, Guillaume. I'm so proud.
Let's go check it out.
Those students answering those questions. We had Skyla and Rebecca and Maddie and Chloe and Isabel and Maya and Dylan and Dimitri and Colin. All of them giving answers like jump and crouch and run. So many more of you. Keep up the great work answering our questions, students. Thanks so much.
And Cam, I just want to say that Cam said there is a score. So that dinosaur can generate points. So every time it jumps over something, it generates points by avoiding. Arham also says the dinosaur can die, which is absolutely true. That's another thing the dinosaur can do in that game. Well, it's fairly passive, but it's still something that we can code in there. So you see, when we just look at a game, and this is a very basic game, but when you look at platform games or open world games, can you imagine the amount of code and all the actions that you can perform in those worlds, it's absolutely insane. So I have a lot of respect for coders and programmers who work on all those things. Brooke and Peter, you have all my admiration. I'm not a coder. I'm just a robotics teacher. So I'm not a programmer, but I really do enjoy video games. So thank you for making this possible for us. I really enjoyed that. So that's our challenge. So we need to recreate that dinosaur game. So in order to do that, we need to head to CS first, Scratch for CS first. So if you were here yesterday, same deal. If your teacher has already set up your classroom, you can log into CS first and then go on your dashboard. And today, if you want, if you're already in CS first, there's a plus sign here, and you can click create a new project. So we'll be working from a blank project. So if ever you're there, you can click the plus sign, new project. So for this video game, there's also for teachers and students, if you want to explore the world of video games a little bit more in CS first, in the curriculum section, if you scroll down a bit, you can find, oh, maybe I shouldn't have clicked that. Anyway, there's a video game unit, so a lesson. So if you scroll down, all the way down, all the way down, all the way down into multi-day units, there is one that is called game design. And this one has 8 lessons, and it lasts between 8 to 12 hours. So there is a lot you can learn in that unit. So students and teachers, if you feel like going further, if you want to improve your game, then this is the place where I recommend going and exploring. All right. So in CS first, we want to have a blank project. So if you're not logged in, no worries, we've got you covered. Remember in that form right here, the form you use to communicate with us, there's a link. And this will give you a link to a blank starter project. Click on that. You can click continue without logging in, and you'll be able to save at the end of the workshop today. So if you click on that link right here, it will take you to a blank project inside of Scratch CS First.
Perfect. Awesome. And I love that feature inside CS First, that if you are logged in, you could just create your own blank project. Or like Guillaume said, if you're not logged into CS First, you can just click that link we put in the form. It's the same link that we have on the screen here. Let us know in the form when you've got the cat, just like Guillaume has. Let us know when you're ready to go. Put that in the form. And Brooke, today you're going to be our student following along with Guillaume, aren't you?
Yes, I am. I'm looking forward to it.
Excellent. And then Peter, I think you're going to kind of take it and run with it and create some epicness. So we'll see.
I'll try.
Wow, these guys are quick today. We have Queenie is ready, and Naya has got it, and Leah from Miss H's class says, yep. Zane in Miss Kirkham's class has the cat. Wow, lots of these students are fast and they are ready to go. Guillaume, I think we go ahead and start.
All right, so let's get this show on the road. So the first thing we want to do in this project is make sure that we have a sprite. So that blank starter project has the cat sprite. At this time, I suggest you keep the cat because we want just to create a demo. But if you want, remember, you can click on that blue icon here, that little cat face, and you can choose your own sprite. So for today, I'm going to stick with the cat because I think it looks pretty friendly. But we will add other sprites later to create obstacles. So don't worry, you'll get to pick your own sprites in a few minutes. So I have my cat, and I need my cat to be able to jump up and down because this is the first function, the first thing we saw in the video game. It's a dinosaur, and the dinosaur jumps up and down. So I want my cat to be able to jump. If you were with us in the first workshop, we worked on the Google logo, and we created a bit of code where we had letters in the Google logo move up and down. So let's take a look and try to remember how we did that in the first workshop. So the first thing we need is an event. So that's in the yellow section. And we need to have a trigger. We need something to tell the cat when to jump. So initially, we worked with when the green flag is clicked, but that doesn't really help us because this will start the game. So we don't want the cat to jump just when we start the game. But we are going to use the second block here, which is when the space bar is pressed, something is going to happen. So when the space bar is pressed. And then, since we want our cat to move, then we'll look in the blue section, the motion section, and we want to change the position of the cat. So in order to do that, we will go here near the bottom of the screen, and you can change the X value or the Y value. So those are our Cartesian plane coordinates, and we want to change the cat, the height, so it's the Y value that we want to change. So I will click that, and I will change the value of Y by 10 to start. So what this will do is that my cat right now, I can see the position of my cat. So my cat is roughly minus 108. All right, so minus 100. So when I press the space bar, my cat should go up by 10. Let's see if that works. So let's test it. Space. Oh no. Okay, space, 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 space. All right, so that works. But my cat is not really jumping. The cat is going up and never coming down. So, Brooke, do you remember how we can make the cat come back down? Do you have an idea?
I think we should change Y by negative whatever value we did positive. So 10, negative 10 maybe.
Exactly. I like the way you think. So in that little box right here, we can put minus 10. So if I read my code right now, it says when I press the space bar, the cat will go up by 10, and then the cat will go down by 10, right? So let's see if that works. I think something's wrong because every time I press my space bar, I don't know. Can you see that my code here is flickering? My code is flashing yellow, so it means my code is running. So it's running now. It's doing what it's supposed to, but my cat is not moving, and I don't know. I'm not sure why.
Maybe it's happening too quickly.
Oh, I like that. Yeah, that's true because computers and code, they can run code so fast that the human eye, we don't detect any movement because it's happening almost instantaneously. So let's try to change that. We need to make the code run slower. So we've worked with controls before, so in the orange section. So maybe we could add a wait block right here. So maybe we could say go up by 10, wait 1 second, and then go down. Let's see if that works.
And Guillaume, these students are on it. Brayden right away said, you need a wait key. We had Olivia and Sophia both said, well, you need to do the minus 10. Like they were in there answering those questions. So great job, you guys.
Excellent. Thank you. So now you can see that my cat, when I press the space bar, my cat is jumping. But it's not jumping very high, right? It won't go over any obstacle at that height. So I guess I need to change the value here in that first blue block. So maybe instead of 10, let's go for 50. See how that works. So let's say I change 50, and then let's try that. Oh, no. Oh, I guess I have to change both values now, huh? Because if I only change go up by 50 and I don't change the go down, then my cat will be, this is becoming kind of a Flappy Bird kind of deal. It's like my cat is flying. So, another classic. All right, so minus 50. Let's see if that works. Go up, go down. Yes, my cat is jumping. Let me know in the form if your cat is jumping as well. Brooke, did you manage to have your cat jump up and down?
So it's jumping, but how do I get it to start at the bottom every time? So like if it's in the middle of the screen now, do I have to just drag it down, or can we set it there always? Like if it stops up high or whatever.
Yeah, that's a good idea. So let's say you run your code and then you stop your code and your cat is in midair and you stop the program like that, then it will be stuck in midair. And when you press spacebar again, then it will start jumping at that particular height. So that is a problem. Good call. So yeah, you can drag it back down, or we can go here in motion And we can say, go to a specific position. So we can drag this block right here. So right now, this block, it's where my cat is right now, the 2 coordinates. And I can say when I start my code with the green flag, the cat will go back to these 2 coordinates. So this is the reset button. So let's see if that works. Let's say my cat is in the middle of the screen. Click the green flag. It starts my code. And then when I press the space bar, it jumps from that position. So I think that's a great bit of code. Thank you, Brooke.
Well,
Awesome.
and Emmy already posted in the chat that that's what you needed to do, is use that X and Y block even before you showed it, Guillaume. So great job, Emmy. I got to give some more shout outs because there just are so many students here telling us that theirs are jumping. So Abby, Rebecca, Annika, Ryan, Dwayne, Ashe, Camaro, and you have a T-Rex. And we have some people that changed it to a dog. Man, so much engagement in the forum. Thank you, students.
Michelle, I can't wait to see the video games that come out of this workshop. And I'm really, really excited because we do see the same names coming back in the chat. So some students from yesterday and some students from the day before. That's just amazing. So your project, I think, will be just out of this world. I can't wait. Okay, so we have the jumping cat, and I want to make sure that we have enough time to add the obstacles, and if we have time, maybe talk about the score. So we'll keep going. So we have a jumping cat. Next, I think it's time to add a sprite. So we need a monster or an obstacle of some type. So let's go in the sprites menu and let's choose a sprite. If you don't have any inspiration, I would like to point out that there's the surprise me button here when you choose a sprite. So this will randomly choose a sprite. So if you don't want to waste any time and you want to have extra time to code, then choose surprise me, and then that will be your obstacle. So what is that? All right, that's a glove, kind of a hand. All right, so I can work with that. So that was a surprise. But you know what? I prefer the crab. So I'm going to remove that sprite with the little trash can, go and choose my own sprite. And I have to say that I think the crab is really cute. I want to use the crab. There we go. Now, at this point, I will just leave my crab next to my cat because I need to make sure the cat can actually jump over the obstacle. So I want to test to see if that works. So my cat is jumping 50 units up in the air. So if I jump, you can see that it only jumps halfway over the crab. So my cat is not jumping high enough, or my crab is too big. So I'm going to go click on the crab, and I will change the size of the crab because crabs are usually not as big as cats. So instead of having the crab 100% in size, I will make the crab 25%. So that, oh, that's maybe too small. Let's go for 40%. There we go. So now I have an obstacle, and if I run my code and I jump, you can see that now the cat should be able to jump over the crab. Right? So it's your turn. Choose a sprite. Any sprite will do. You can choose a tree, you can choose the crab, an alien, the bowl of cheese puffs, anything you like. It doesn't matter. And insert that sprite and change the size. So, Brooke, what did you choose?
I chose a unicorn and a rock. So my unicorn is going to jump over the rock.
I like that. And Peter, in your game, can we have a sneak peek into your universe?
I was very boring and I chose a cat, but I chose a car for the cat to jump over.
Okay, I like that.
And Guillaume, we have Zoe is using a pig. Austin and Lev are both using dinosaurs. Aisha is using a unicorn and a rainbow. Wyatt chose a rock. And also Brookie is out there. And every time, Guillaume, you say Brooke's name, Brookie thinks we're talking to her. Hello, Brooke.
Oh,
and Brookie, keep going.
All right. So now it's time to have the crab move. So these obstacles in the game, they have to start on one side and they have to move all the way across the screen, and then we need multiple sprites. So at this point, there are many ways to code this, and I'm going to show you a simple way to code that. But if you explore the video games unit, you will discover that there are other ways. And when you take a look at Peter's game, my guess is he's a lot better than me at coding, I am sure. So he might use other techniques. So I'm going to show you one technique. So that little crab right here on the right side, we need to make sure that we code the crab. So it's not the cat that we want to move from one side to the other, it's really the crab. So click on your sprite, and you'll notice that right now it doesn't have any code. And what we want is motion. So we will start with a block that says when we start the code, so when the green flag is clicked, and we want motion. Now in this case, we don't want the crab to appear at the other side of the screen. We don't want the crab to teleport from one side to the other. We want the crab to glide from one side to the other. So that's what we want right here. So we want glide in 1 second to this specific position. All right. And that position, well, this at the moment, this is our starting point. See, so 208 and minus 166. Well, I just clicked on it, so it moved a little, but that's our starting position. So I'm going to show you a little tip. Let's get rid of that. And I will move the crab to the left side of the screen. So I'm going to make sure that the crab arrives on the left side of the screen, and it needs to be, we need to lose part of the crab outside of that screen, outside of the square here. It needs to go across the border a little bit. So now I will use glide. And you can see here that when I put the crab where I want it to go, that position, those numbers are already the right numbers. There's nothing to type in. So that's the first part. So the crab will glide from one end of the screen to the other. And we want the crab to start on the other side of the screen. So after it glides to the side, it needs to go back to the other side of the screen. So I can say, go to this position right here. So it moves to one side and then teleports to this location here. And we need this to repeat. So let's go. In order to repeat, it's in controls and forever. Let's go that. With forever. Let's see if that works. I hope it works. So we start code, and the crab moves from one side of the screen to the other, and then it teleports back to the beginning. So now we have the impression that it's several crabs running at the same speed, starting from the same position and going to the other end of the screen. So we have a running crab, and my cat can jump over the crabs, but maybe my cat is jumping too long, it's difficult, or the crab is too fast. So I think we'll need to adjust a few things.
Wow, so simple. Like, oh my goodness, that makes so much sense, and it totally looks like it's moving just like the dinosaur game. Brooke, how is that for you? Did that all of that make sense? You followed along with that?
Yep, mine is moving as well. One thing that I noticed is that when I stop it, though, the rock kind of just stops wherever. So I use the trick that we learned before when the green flag is clicked to start it at the side, because I like it to always start in the same place.
All right. So at this point, I want to point out that we have when the green flag is clicked. So we have that code right here. But if you want, you can also add a new one. So when the green flag is clicked, you can have another piece of code that will run at the same time in parallel, right? Or you can add your motion. So let's bring that little crab back to the beginning. And then in motions, we can say, go to this starting location. So when we click on the flag, the crab teleports to the starting location, and it runs and teleports back forever. Does that make sense? I hope it works. So let's stop it. So the crab is in the middle of my screen. If I click the green flag, yes, it did work. So it started back to its original position. So thank you, Brooke, for that comment. So it's a great way to fix that. Okay, now I think we have the basic mechanics down. But the only thing is, I think that game is not, it's not playable yet. There are some things missing. So, for example, we can clearly see that if the crab touches the cat, it has no effect. So there's no way to lose the game. There's no challenge because even if you don't do anything, the game just keeps on going, and you can never die, and you can never win. So that's not really a game, right? So I think we'll need to fix something. And there's also the issue of the cat maybe jumping not high enough, or being in the air too long. That's your job. Okay, I'm just going to point it out how you can fix it, but I'm not going to fix it for you. I'm not giving you the answer to this one. So remember, in that first, I'm back on the cat, okay, back on the first sprite. Remember that we said change the value, change the height. So this is how high the cat is jumping. And the other one is how long the cat will stay in the air. If you change this number, you can adjust the height. If you change the other number, you can adjust how long it will float in midair before coming down. So that's the first thing. If you want to remember that, I'm just going to show you a little something. If you right-click in an empty space, so right-click in the white space, there's a way for you to add comments to your code, right? And this will create a little post-it. In that post-it, you can leave notes. So this is my jump code. And maybe if you're coding with someone else, or I'm sure Peter and Brooke, when you code, maybe you leave comments in your code for other people to see, or maybe codes for you. Am I right? You leave comments in your code sometimes?
Yes, leaving comments is super important when you're working in a team, because you need your teammates to know what it is that you're doing.
All right. So for example, I say, no, my jump is too high. Maybe I need to adjust that. Right? So I need help fixing my jump height. So in that case, when I see this note, I know that this code is to jump and this code is to teleport somewhere else. So you can identify different parts of your code to help you stay organized and not get lost in your code. Because when you see Peter's code, I haven't seen it yet, but I'm guessing that his code will be probably a little bit more complex than ours. And so it might help us when you create something really complex to keep notes for yourself in there. So we can add that. All right. So you'll need to fix the height of the jump and the length of the jump. And for the crab, maybe 1 second here, maybe it's too fast. Maybe 3 seconds would give us more of a chance to be able to avoid that crab. So you see when you change, I think that's better. See, I just changed the glide speed, and now I can jump over the cat. And this game is, I think, a lot better.
We have some pretty proficient CS First for Scratch users out there. I think I've got to give some shout outs over. So Ayashita talked about the timing, changed it to 0.5 seconds, which was perfect. Leanne in Miss Cavallo's class is so happy their game is working out so well. Emerson is kind of giving you a hint for what you're going to need to do next. Says that we should probably go into sensing. And I think you're right, Emerson. Awesome. Piper, we've got lots of people using crabs. Piper's using a crab. Audrey's using a crab. Caden, I'm not coding because I got to keep up with all of you trying to communicate with us. So thank you guys all for that. Keep going.
All right. So now the next step is to have the crab interact in some way with the cat, because we want the game to be able to know if we're losing a life or if we're game over or something. So in order to do that, we are going to switch to the crab, and we are going to start a new section here. And when we click it, we want the crab to verify at all times in a loop, right, if the crab is touching the cat. And if it is, we need to die. The game needs to be over, because that's how the game ends, right? So in order to do that, we need to go into sensing. So you were right, in the light blue section, and it's the first block here. So let me take that block and drag it here so it's a little bigger. So it says if, well, this is touching the mouse pointer. But if you click on the drop-down menu, then you can say, oh, if I touch the edge, or if I touch sprite number 1. So sprite number 1, you can see here that my cat has a name, and it's called sprite number 1. So this is a condition I can sense if the crab is touching something else. So in this case, it could be the mouse pointer. So I have other ideas for other games, but we're doing a Dino game today, so don't wander off with the mouse pointer just yet. So I want to know if I'm touching the sprite. But you'll see this block has a special shape, and it won't click, it won't attach itself to other blocks of code at the moment. So I need to find a way to fit this block into something. It needs to attach to something else. So in order to do that, let's take a look in the control section, and there are if blocks right here, right? And you'll notice that this has a diamond shape there. So if I bring that here and I let it go, there we go. So this will give me, if the crab is touching sprite number 1, then something needs to happen. So the something here, what could it be? A game over screen, or maybe the cat will die. Maybe the cat will fall down. This is entirely up to you. So for me, I think I will make the cat just fall down. So let's see if I can make this happen. So in order to do that, oh no, I'm gonna go with a game over screen. I think that's better. So let's go here, and we need to change the backdrop. So at the moment, we don't have a backdrop. Well, we have one, it's white. So let's go here, and we will paint our own backdrop. And we'll create something fairly simple. I'm just going to use text here, and I will type game over. And I told you before yesterday, I'm not a very artistic person. So today, the only thing I want to show you is how to create your own backdrop, but you will make it better than mine, I am sure, because we don't have a lot of time today in the workshop. So I'm just going to say game over. You can make this a little bigger. You could adjust the colors if you wanted to. So I'm just going to say game over. And you can see here on the left side, if you look at my mouse, there's backdrop number 1, which is white, and then backdrop number 2, which says game over. So I think that's good. Let's go back to code right now. Okay, so just to repeat, I clicked choose a backdrop, paintbrush, just the text option, and I just typed in game over, and that created a second backdrop for me, right? I go back on the crab, and then this is here. So I need to switch the backdrop if ever the crab touches the cat. So to do that, let's go into looks, and we can switch costumes, but we can also switch the backdrop to something else. So this code, if the crab touches sprite number 1, we switch to backdrop number 2, and backdrop number 2 is game over. So if I do that, it will almost work. And I have to refer to Brooke once again, because I think the solution she gave us earlier, I think it's the best solution for this one too. When we start the code, we need to make sure that backdrop number 1 is up. Otherwise, I'm going to start my game, and it's going to say game over on the screen before I even start. So that wouldn't be fun. So let's go here and switch backdrop. And I'm going to use this at the very beginning here, right after my flag, switch to backdrop number 1. So let's see what happens. Start the code. There we go. And, I was sure that was going to work.
Hey, Guillaume, just before you go into troubleshooting that, Griffin deleted their sprite, which also deleted all of the code. Is there any way to get that back?
You can go here and you can try to restore the sprite, but sometimes it doesn't really work all that well if you didn't save your project. So it's not a big code. So you can always press Control-Z to see if you can undo your changes or something. But it does happen sometimes that we lose the code. So that's why it's important to give it a name and save your code. So here in File, you can save it to your computer. or save a copy of your code from time to time. But it's only a demo today, so if it's not the end of the world. And I'll give you screenshots of working code later, just before we leave. So you'll be able to take a screenshot of that and use it and copy it if ever you need.
Brooke, have you ever lost code?
More than once. It's very sad when it happens, and you try to learn from your mistakes, but you don't always do it in a timely manner, and then you lose it twice. And then you really learn.
Yeah, happens to the best of us, I guess.
It does.
All right. So my code is not working at the moment, but you'll notice that I'm not crying and I'm not angry. I'm not throwing things at my screen. I'm just looking at my code, and I don't know if you can see this on your screens, but you'll see that this section is highlighted in yellow, meaning that it's running at the moment. But look at the new condition. Look at this one. There's no yellow. It means this code, for some reason, is not running.
Or did it run and now it's done, so it's not running anymore?
Oh, so that would mean, this is what Peter told us before. Remember, when we code something, the code runs so fast that sometimes we don't even see it run. And I think this is the case because when I clicked on the flag, it switched to the backdrop, it verified if it was touching the cat, it wasn't, and then boop, it fell out of this code. So this code only ran once at the very beginning, in 1 millisecond at the beginning of our code. So that's what's missing. So we need a loop. So we need a forever loop like this. So let me stop my code so that my changes will be taken into account. So if I'm not mistaken, if I do that, so let's move the crab back a little bit, do that. Oh, now it's yellow, it's running. And yes, we did it. So by staying calm and by looking at the code and reading the code out loud, I was able to debug my code. And I knew there was something wrong with that section because it wasn't turning yellow. So that's how you can debug your code in Scratch for CS First. Okay, now let's see if this works. One more time. I want to jump over my crab. Jump. Yes. That's working. All right. We have a working game. Now we can lose. And I think we have just enough time to see if we can win this game. We need some kind of score. So do we have time, Michelle, for the score?
I think we go for it. Can you just before you jump into that, can you just go back to your code for your cat? We had a request to see that code. There it is. Those that need the code for the cat, pause right now so you can see that. Now we're going to get into keeping score. Let's do it.
Okay. So in order to keep score, we need to introduce something a little bit geeky. And follow along. And remember, you can always press pause and you can rewind and watch it again. Okay. So in order to keep track of the score, we need to know if the crab touched the edge of the screen. Because we know that if the crab touches the cat, then it's game over. But we are going to use the same code, or almost the same code, and you'll see, I'll show you how to do it. And we want to detect if the crab is touching the edge. So instead of going back and finding all the blocks of code and dragging them one by one, look, right-click on a section of code, and there's the option to duplicate that code. And look, ta-da! So now we have two identical sections, and here we just need to adjust the conditions. So we can start with a block of code that we've already made and make a few changes to make sure that it works for what we want. So that code here, switch to backdrop 1, well, I think that works. Maybe we can leave it there and we'll see if it creates a conflict later on, but I don't think we need it, but we'll see. And here it says, if we're touching sprite number 1, but I remember earlier when we clicked on the drop-down menu that we could see if it was touching the mouse pointer or touching the edge. So if I say edge, then it will switch to backdrop number 2. No, wait. So if I leave it like that, if the crab reaches the edge of the screen, it will say game over. Oh, no, that's wrong. I don't want that. So let's get rid of that. So I'm just going to click on switch backdrop and drag that to the side. and delete that block. We want to create something else. We want points to go up. So at this point, follow along on my screen because this is the geeky part. All right. So follow along. In the orange section, the one before last, it says variables. Now, variables are very useful when we're coding because it's like memory. It's like a suitcase. So variables, we can put things in the suitcase and then bring that with us somewhere else and then use what's in the suitcase later in our code. So it's like remembering or bringing things with us in the code. So at this point, I want to create my own variable. So I will click on that white block right here, the first one at the very top, make a variable. I will call it points. So variables, make a new variable and call it points. You'll notice that points just appeared in my game right here. So that variable is now visible in my game. So I can do something with that variable. And if I'm still here in the variables section, and you can see that I can set the variable to 0. So I think I'll do that. So when we start the game, I want the points to be equal to 0. So that's the same as making the position, the starting default position. So making the variable 0. So let's keep that. The backdrop, maybe we don't need the backdrop. Let me get rid of that. So I'm editing my code and reviewing this code. So the variable is set to 0, but then if I touch the edge, I can change variable by 1. Okay. Now, if I run this code, I almost made a mistake. My variable is called points, and this one here says my variable. So there's a drop-down menu right here. So you need to go down and choose points. Same thing down here. Drop-down menu, scroll down, points. So if I read this code out loud, when the green flag is clicked, I make sure the points are 0. I'm starting the game 0 points. And then this will repeat forever. If the crab touches the edge, I will add 1 point. So I'll open the suitcase, put a point in, and then repeat that. And those points should be shown right here, top left corner. Whew, let's see if that works. Green flag. The code is yellow. It's running. Oh. So it's working. So the only thing that's happening now, you can see that my points are going up faster a little bit. That's because the crab is touching the edge just a little longer than 1 millisecond. So we score a few points every time the crab touches. But then you can fix that here by changing the number of points, because maybe you want it to be 100 points every time the crab reaches the edge of the screen. So that's the code we need, and I think it's working well.
I got to give a shout out to Mohammed and Makram because they suggested using variables like way earlier in this broadcast. So nice suggestion. Glad we had a chance to show those variables. We are running out of time, Guillaume. What do you think?
Yeah, I think it's time to showcase what Brooke and Peter have come up with. Maybe there's just one little detail. I won't do it, but I just want to say that it's out there. In the green section, there is a way to pick a random number, right? So remember when we adjusted the speed of the crab, we said go there in 1 second or 3 seconds. Well, you can pick a random number between 1 and 5. So that will make the game different. So sometimes the crab will go slowly and sometimes it'll go faster. So you can use that pick a random number that's in the green operators section. And Michelle, if you just leave my screen up for just a second. Let me just bring that back up.
And while you're bringing things up as well, we need to give a few more shout outs. Abby, you're not bugging me at all. Thank you for saying this is amazing. And Griffin, you got so much support out there. People felt bad that you lost your code. Quinn, sitting right beside you, also thought that was too bad, but hopefully things are going okay. Brady, love that you talked about using decimals. Look at this. We're doing math. We had Queenie. I don't know, Queenie, if you'll come back. Was so sad. It was lunchtime and they had to go. When do you have students sad that it's lunch? All right.
That's a
And
good sign.
Lillian feels like this just makes coding so easy. So thank you, Lillian, for letting us know that. All right, Guillaume.
Good. So there's one of the skills in coding that also implies that when you see code, you can try to read it and try to figure out what it does and see if it might be useful in your own code. So this one is a code a little bit more complex. If you want to take a screenshot of this one actually has gravity integrated into it. So the cat will jump and then go down until it sees the color black. So if you have a backdrop with a black line at the bottom of the screen, then the cat will jump and reach and come back down, and this will simulate gravity. You can also use the arrows to move other ways, and you can also switch costumes because the cat can be animated and you'll get the feeling that the cat is moving. So here's the screenshot for the crab. You can integrate sounds also there, and you have how to count points. You see here that I used post-it notes to comment my work. And finally, this is what I was telling you about earlier. So if you want to add other sprites, other obstacles, and this way you get to show or hide certain obstacles, and you can also use the pick random time here. So you'll have crabs and then trees and then I don't know, flying dinosaurs or something like that, or rainbows in the sky. So it's entirely up to you. You get to create something amazing. And I just wanted to share those screenshots just in case you lost your code or in case you wanted to go a little deeper and try something next level, something a little geeky if you feel like it.
And it's so great, students. This video, remember, is recorded. So quite likely your teacher can even pass on the link and you can watch this later and go through this and dive deeper. I also love some of the suggestions that have come in. So for example, Makram is using themselves as their sprite. Right? And so we could either bring in graphics from the internet or take pictures of ourselves. The sky's the limit. Brooke, are you ready to show us what you've got?
I'm ready.
Okay, we'll
Go
put
ahead.
your screen up. Here you go.
Okay, so I chose a unicorn. Let me just make this a little bit bigger. And so if we go, we jump. Oh, I lost. But one thing I did add while we were talking at the very end there was a you win screen.
Yes.
If you hit 10 points. It's very exciting.
That's awesome. And you did that just in this time, following along, Guillaume. Students, I know you guys have amazing work too, and hopefully your teacher will be able to get that to us. We'll give you details on that in a second. All right, students, if you're not watching the screen right now, you probably want to stop what you're doing because I think Peter probably has an epic dinosaur game. Peter, are you ready to show us your work?
Sure. I think I've got two different games. So this is the one that I was coding along with you guys. So I've got a bird going across the screen as well as a truck, and I was trying to make it so that the cat can jump on top of the truck. It doesn't really work, but that's what I was able to do within an hour. And I'm going to see if I can share a different tab to show what I did this morning.
How long did you work on it this morning?
Maybe 2 or 3 hours.
Oh, that's awesome. All right, let's see what you can get done in 2 to 3 hours. Holy.
Okay, so I've got the monkey. The monkey is jumping on top of the trees. The monkey also can skateboard on top of the platforms.
Oh.
And if it doesn't, and if it gets stuck in the puddle, then it needs to get rescued, and it's the end of the game.
Amazing. I love that. Love that so much. Hey, Peter, can you go back to your code? We're just going to show students one more time how they can save their files. So go back to your code. So students, when you're ready to save this to get to your teacher, so your teacher can send it to us, you're going to go to that file menu and you're going to see, does it say save to my computer, the very last option? That's going to save an SB3 file. It's a Scratch file. And then teachers, you put all of your students' Scratch files inside a shared folder or a Dropbox. You're going to get that to us, and then we're going to put those students' projects up on our studio. But students, remember one thing. We want to keep your information private. Please don't put any of your own personal information in there. Don't put any personal identifying information in your code. If you do, we won't be able to include it. So with that, let me jump back to our slide deck. While I'm doing that, Guillaume, are there any other names in that form that we need to give final shout outs to?
Oh, I'm sorry, Michelle. I wasn't looking at the form at the moment. I was looking at Peter's code because I just wanted to highlight the number of green blocks in his code, because every green block is a math block or a logical block. And I thought that was really good. It's rare that I see that many green blocks, that many comparisons or Booleans inside a game like that. And I can't wait to see all the studios, all the projects that we'll have. We'll have skateboarding monkeys next to flying unicorns and cats jumping over crabs, and we'll have all sorts of amazing things. So I think this is going to be really intense.
Awesome. Well, all right then, students. We'll be back here next Wednesday for the student showcase. We're going to have Googlers back with us. We're going to have all of your projects that your teacher submits. We're going to have them in a studio, and then we'll be able to give more shout outs next Wednesday. So hopefully you can join us. And if you didn't get a shout out today, we're so sorry, but we do want to say thank you again to Google Canada. We want to say thank you to CS First in the States. Thank you, Brendan, for joining us today, Cassandra, for everything you've done, and Josh. We hope to see you next week at the showcase. And with that, students, that's the end of our challenges. Teachers, check your email for how you can send us those student projects. We are so excited to see them. Brooke, thanks for being here again. Peter, thank you for being here. Amazing game. Guillaume, thanks for walking us through and making it so easy. And teachers, thank you so much for bringing your students to us. So have a fabulous rest of your day. Bye-bye.
Bye.